Our new topic is solving systems of equations by substitution. So you're not always going to be able to solve a system of equations by graphing it, because what's going to happen if you graph two equations and you get this as your system? What we went over previously is that the answer to a system of equations, when you graph it, is a point they have in common. But how do you know what point that is? Is it 1 1/2, 1 1/2? 1/2, 1 1/2? I don't know, right? It's in the middle. It's not on a grid mark. So we need other ways to solve this kind of equation. And we're going to do it algebraically. So this entry is called solving systems by substitution. And when we solve systems by substitution, what we're really trying to do is, if we have a system like, and don't write this down, this will just be an example, x plus y equals 4, and 2x plus 2y equals 14. Okay. We're trying to manipulate these equations, do some algebra to them, so we can get it down to one equation with one variable. Because if we have an equation with one variable, like x plus 3 equals 7, then we can solve for x. And once I know what x is, I can solve for y. So we need to manipulate these so we can eliminate a variable and figure out what that variable is as a number. And we have step-by-step process to do that. So your handout is this page right here. Okay. You're going to cut out along the outer box and then cut along the dashed lines here. So these will end up folding in as tabs. So you can pause the video and go ahead and do that. Now that you have this cut out, we're going to look at the first step to solving this system of equations. Our system is x minus y equals 1, and 3x plus 2y equals 8. So my first step is to solve one equation for one of its variables. Does it really matter which one I solve for first? Solve for x or solve for y? It's not going to matter in my answer, but it is going to matter on how difficult the problem is to solve. So generally, when we pick one of these equations to solve for one of the variables, we're going to choose the least complicated one. What is the easiest one to solve for? In this case, it's this first equation, and it's x, because there's only one step to get x by itself. We add y to both sides. When we add y to both sides, we get x equals 1 plus y. And I rewrite my new system. It's the same thing, it's just this equation is written differently. I haven't changed the value of anything, just the way it looks. Now, the second step is to substitute the expression found into the equation not used. Solve for the other variable. Okay. This is kind of wordy, but by solving for x, we've realized that x equals 1 plus y. I'm going to box that in another color. So x and 1 plus y are the same thing. They equal each other. And what we're going to do is we're going to take this expression that x equals, and instead of using x in our equation, we're going to substitute in the expression 1 plus y, because 1 plus y and x are the same thing. So it is substitution. Normally we would substitute a number in. Like if x is 3, we'd put 3 in for x. But in this case, x is an expression. So we're still going to put it in. And instead of 3x plus 2y equals 8, we have 3 times 1 plus y, which is our x, 1 plus y, plus 2y equals 8. And by doing that, we have an equation now with one variable, and we can solve for y. So we distribute 3 plus 3y plus 2y equals 8. Combine like terms. 3 plus 5y equals 8. Subtract 3 from both sides. 5y equals 5. Divide by 5. Y equals 1. So we just solve for y as a number. Right, and that's the point. We want to solve for the variable as a number. So y equals 1. Now if I know y equals 1, how can I find x? Well, x is 1 plus y. So if y is 1, then x must be 2. And to show that algebraically, we substitute the value found for the second variable into the equation found in the first step. So it's a wordy way of saying we know x equals 1 plus y, but we know that y is 1. So x equals 1 plus 1, x must equal 2. So my solution is 2, 1. But I also have to check. And to check my solution for a system of equations, I have to put these answers back into the original system. X minus y equals 1, and 3x plus 2y equals 8. So x minus y equals 1. Does 2 minus 1 equal 1? 1 equals 1, so it works for the first one. 3x plus 2y equals 8. 3 times 2 plus 2 times 1 equals 8. 6 plus 2 equals 8. 8 equals 8. So they both check out. So this is the solution. Substitution is probably the most difficult one to use because it involves a lot of algebraic concepts that this year you're just getting familiar with. Our new system is 3x minus 3y equals 33 and 4x minus 2y equals 16. We're going to work with our first step, which is to solve one equation for one of its variables. Now this one was a little easier, right? We solved this one for x by just adding y. It's a little more involved in this one. So as you start doing more of these, you're going to figure out which one is easiest to use. And the faster you figure that out, the easier these problems become. For me, when I look at this system, I see that this is a 3, this is a 3, and this is 33. So automatically I know that they're all divisible by 3. So I know I can work with that. These ones are all even. So I could work with that too. But something about this one just makes it seem easy. They're all 3's. So I'm going to start with this one. 3x minus 3y equals 33. And I'm just going to divide everything by 3 right away. And I have x minus y equals 11. And I'll add y to both sides. And I have x equals 11 plus y. So I know what x equals now. X is 11 plus y. I have what x is as an expression. And let's rewrite my new system here. X equals 11 plus y, and 4x minus 2y equals 16. And now, solving by substitution, I know what x is as an expression. It's 11 plus y. So I'm going to put it into my second equation. So this becomes 4. And instead of multiplying by x, I'm multiplying by 11 plus y. Because that's what x equals. Right? X and 11 plus y are the same thing. They equal each other. So this is 4x minus 2y equals 16. But by substituting, I've gotten rid of the x variable, and I have an equation with one variable that I can solve. Distribute the 4 in. 44 plus 4y minus 2y equals 16. Subtract 44 from both sides. 4y minus 2y equals negative 28. Combine like terms. Divide by 2. Y equals negative 14. Now my last step, if I know what y is as a number now, I want to figure out what x is as a number. I know from my previous step that x is 11 plus y. If I just figured out that y is negative 14, then x is really 11 plus negative 14, or 11 minus 14, which makes x negative 3. So my solution, I believe, is negative 3, negative 14. But of course we want to check and make sure that's right. And whenever we check, we use our starting system of equations because we don't know if we made a mistake here. So I don't want to check from this point. I want to check from this point. My first equation is 3x minus 3y equals 33. It's 3 times negative 3 minus 3 times negative 14 equals 33. Negative 9 plus 42 equals 33. 33 does equal 33. Checks for the first one. Now what about the second one? 4x minus 2y equals 16. 4 times negative 3 minus 2 times negative 14 equals 16. Negative 12 plus 28 equals 16, and 16 does equal 16. So it works for both, which means my solution is negative 3, negative 14. So solving by substitution is a pretty lengthy method, and it does require a lot of algebraic concepts, but you can definitely do it, and at some point it is necessary to solve by substitution when you can't graph them. In the next entry, you're going to learn a different way to solve, a different way to eliminate one of the variables. Your goal now is to solve this system, 8x minus 10y equals 10, and x minus 5y equals 20. using these steps. And when you're done or you need help, please ask your teacher. Now that you've completed your foldable, you've done this problem, you checked with your teacher and the teacher told you that -5 is the correct answer. You're going to make sure that these tabs are cut along the dashed line just up to this crease here, and you're going to fold these in like windows. The same on this side with the window. Now you don't have to fold them in. It just makes it so it's a little less visuals to look at, so it doesn't come jumping at you for each step. And once you get it in, you can either glue the back of this or just put a piece of tape here, piece of tape at the bottom, and then you're good to go.